Hello! Today's lesson should be a very simple and straightforward lesson. It's that if you have a product of two things, I don't want to say numbers because they might be more complex than numbers, but if you have a product of two unknown values or two unknown expressions, one of those factors or both have to be zero. Either the A is the zero, the B is the zero, or perchance they're both zero. So we're going to use this in order to solve equations that have factors or a product of things that is equal to zero. For simplicity, let's start with the very, very simple one. If I have x times x equaling 0, well, there's only one possibility for that actual expression. That's x is 0, because that's technically x squared equals 0, right? So there's only one solution for that, or they're both factors are 0. But now let's change it a little bit. In other words, let's say one factor is x, and the other factor is an x plus 1 equal to 0. Now, it's not just simply x times x, but it's still a product of two factors. One factor is x, one factor is 1 larger than that. The way you solve this is you set each factor equal to 0. So I'm going to take the first factor, which is x, and I'm going to say, well, either that first factor is 0, or I'm going to take that second factor, which is an x plus 1, and set that equal to 0. And I solve that for x, so x could either be, because when I minus the 1 over, x can either be -1 or 0. And try it, plug it in. If I plug a 0 here, 0 plus 1 is 1, and 0 times 1 is 0. But if I plug a -1 in, -1 here, but what's -1 plus 1? That's 0. Now I got 0 times -1, and I get 0 again. So there's actually two solutions. Now they're going to continue to get more and more complex for these two factors that they give you. They might give you x minus 3 as one factor times x plus 7 as another factor, but that product will always equal 0. Well, again, I take that first factor, that x minus 3, which is equal to 0, or could be equal to 0, and I solve it for x by adding 3 to both sides, and I get x is a positive 3. But we got to also do that with the second factor. X plus 7 equals 0, minus 7 from both sides, and I find out x could be -7. So I get these two solutions of a positive 3 for x and a -7 for x. Now, just as a forewarning of where we're going, they won't give it to you like this in the future. We're not going to do it this lesson, but this expression would actually be given to you as x squared plus 4x minus 21 equals 0. And the funny thing is if you plug in these values, if you plug in a 3, you're going to get 0. 3 squared is 9, plus 4 times 3 is 12, 9 plus 12 is 21, 21 minus 21 is 0. If I plug in a -7 is positive 49. Plug in -7 here, that's going to be -28. Well, guess what? -28 and -21 is -49, plus the 49 is 0. You're not going to have to do that yet. You're just going to have to solve it for two factors. But again, they might even get more complex than what I've given you. So for instance, they might give you something like this. 3x plus 4 times 2x minus 7 equals 0. Again, same exact principle. I'm going to take each factor, each set of parentheses by itself, 3x plus 4, set it equal to 0, and solve. Minus the 4 over, 3x equals -4, divide by the 3, and I get x is a -4/3, which is a perfectly good answer. You can have fractions as answers. Now we're going to do the same thing with the second factor. 2x minus 7 equals 0. We're going to do 2x equals 7 because I added 7 to both sides. divide by 2, and I find out x could be 7/2 or 3.5. I get two solutions because either the first factor is 0, the second factor is 0, or they're both 0. But again, if you have any questions on this, please bring them to class. But just remember, whatever factors they give you, whatever sets of parentheses that are being multiplied together that's equal to 0, make sure you just set each of those separate parentheses equal to 0 them individually and solve.